So quadratic functions, the real cool thing about this section is that it gives a pretty neat introduction to graphing functions of higher degree besides 2. If the degree is 2, then we basically say that's a quadratic function. And so all quadratic functions look alike. They have that parabolic shape, whether it's shaped up or shaped down or to the left or to the right. We'll take this idea that you'll learn in 2.2 and apply it later on to functions where the degree is like x to the third, x to the fourth, x to the fifth. It doesn't matter. Pretty cool thing is that if you're going on to calculus, you will even see more intricate details of how we can actually map that out by using some other concepts. But to be honest with you, I think the best way of doing it is right here in this class. I think once you get it here, believe you me, it really undergirds everything you will do in higher mathematics and also in physics and other engineering courses. So this class is really the key to most everything that you're going to do ever when it comes to mathematical sciences. That includes, again, physics and also engineering. So this section is pretty cool. We want to be able to eventually graph a quadratic function by finding the vertex. Now I'm going to show you the old school method because that's just how I learned it. And the way I learned how to do this, again, I told you in the beginning, my concept of sharing with you this information is not for you to memorize because I can't because of just my weaknesses. But what I can do is show you how I see things, and from simple images, I can get what I want without trying to have a whole lot of stuff in my head. So I will show you that. Now, if you want a formula, they have some neat formulas here in this book and also in my math lab. If you want to memorize that stuff, fine. I really struggle with all of that. So, but what I do is I remember certain concepts like completing the square. If you can remember that, and I'm going to go over that today. If you can apply that, you will get the vertex automatically. And you will get all these neat things just about the quadratic function and the quadratic equation all by itself. So we'll look at that. So let's see. And don't forget, next Tuesday, next Thursday, please, if you could set some time out. Again, I'm going to be giving the retake for test 1 on next Tuesday, and then the retake for test number 2 on Thursday after class, okay? So here, the vertex of a quadratic function. Now what they've done was to go from this guy, f of x equals to ax squared plus bx plus c, and they were able to write it in this form here. Now, how did they do that? They got this form by completing the square. Complete the square on ax squared plus bx plus c, and you get what you want. Now, what do you want? Well, we like that a sitting out there by itself, and then we like that h and that k. You see the h and the k? Well, the h and the k, if we can get this guy and get that number, then that gives us the vertex. Now, that number h, just say x equal to h, and that is called the line of symmetry. So I get it by completing the square. They put a formula in here for the vertex. Pretty cool. Once you get to calculus, you're going to realize that this formula for the vertex is just the derivative of the quadratic function. Pretty neat. But anyway, who cares about that now? If A, that number A, where is A? That's A here. If A is positive, then the parabola, which is a cup, I was drinking my coffee and I didn't bring the cup, but if A is positive, the cup sits up like this. If A is positive, then you always have a minimum. Let's see. If A is positive, well, probably not good to say that. Let's say I. If A is positive, then we have a parabola, and this is just basic. Okay, so the parabola is shaped up. I'm going to always have some kind of minimum. If A is positive. Secondly, if A is negative, then we have here a maximum. If A is negative, that number A is negative, then the parabola, that's not good. The parabola is shaped upside down. And so if it's shaped upside down, that means I have a highest point. That's at that vertex. Okay? We can find X intercepts, Y intercepts, and we'll look at that when we take a problem to consider. And they're just given just illustrations. This 0, 0 is the vertex if the function looks like ax squared, right? But then the vertex can shift. It can be anywhere. So I get this h, k, wherever they are on the xy plane. Here A is positive, so the parabola is shifting up. Right? On the right side, A is said to be negative, and so the parabola A is negative, so the parabola is going down. So I have some maximum. Maximum there if A is negative. If A is positive, I have a minimum. And the minimum or the maximum will be the vertex for the so-called parabola. Let's see. Again, this is the formula that they give. You're welcome to use that if you want to get the vertex. So here's what they're saying. If ax squared plus bx plus c, and it should be if f of x, if f of x is equal to this, then the vertex is this value for x that they get is this negative b over 2a, and then you evaluate the function at that particular value, and we get the value for x and y. This was the guy that I was saying, if you can remember that. If you can't, then I complete the square. So here's the note. We also get this value automatically by completing the square. And I will say this, you take your choice. If you want to, be old school like me and complete the square and get the vertex, that's fine. If you want to use this formula, if you can memorize that, I'm cool with that. But check this out. Don't do this. Don't try to put all your eggs on this formula and you don't complete the square, and then you take the test and you can't remember the formula, right? And then you ask me, what's the formula? Well, I'm soft, I tell you, but you know, no, I try to be hard, man. It doesn't work. So here are the steps. I mean, those steps are good. I'm going to leave them there. You can always have this page for reference. But my thing is, I'm going to work some problems, and as I work the problems, you'll see these steps really come alive. Okay? So here in this exercise, find the coordinates of the vertex for the parabola defined by the given quadratic function. Now here was something that I think is important that I better go back and make mention of, and that's this. You see, when they give this equation here, they're saying a whole lot. They're saying if you have the equation in that form, you can just look at and extract, pull out from it the value for h and the value for k. That value for h, see that it says x minus h? So what happens if it's x plus h? Then you understand that to be h is going to be negative because the formula calls for that negative. X minus h. So if it's x minus h, I'm talking about this guy, that's in the formula automatically. So I got to have that. If I don't have it, it's understood to be a times x minus a negative h, all to be squared plus k. Because that minus gives you a plus sign. So if it's a plus sign, that's understood that h is negative. But if they give me the problem and it looks like this automatically, then I can just extract from that, okay, my vertex is h comma k. I'm done. Let's look at this problem. So this problem is already in that form that we want. I can look at that and tell that the vertex is h, which is the 1, and the k is negative 3. So 1 comma negative 3. That's it. Because it's of the form f of x is equal to a times expression x minus h to be squared plus k. Does that make sense? Okay. Let's look at this one. So what's the vertex for this one? Negative 1 comma 3. See, the form is f of x is equal to a times x minus h to be squared plus k. Well, the plus k is already the plus 3, so it's just 3. But here, it's supposed to be x minus h. Well, this is x minus a negative 1. So if it's x plus a number, you understand that number to be negative, right? Because the form says, I got to have it like this. So let's make sure, that we remember this. Right. So complete the square to find the vertex. We're going to factor out a from ax squared plus bx. So we're not going to consider the c, just take out the a from those first two terms. Take half of the coefficient of x, square it, add it, and subtract it within the parentheses. That's really the crutch of completing the square. After that, take the negative part out. What's left in the parentheses, that's a perfect square trinomial. Just factor that. I mean, that's going to be beautiful. I mean, matter of fact, you're doing the work. You up under the hood, you know, taking those bolts off, changing that oil, and then once you get through, you crank that Chevy up. Zoom, zoom. You see what I'm saying? It sounds good. It sounds good. So here, completing the square, you up under that hood, you're taking the 1/2, you're squaring it, you're adding, subtracting, that's all up under the hood. And then when you get through, you crank it up, that's that perfect square trinomial. It's smooth, it's smooth. And so when you're done, the results, if done correctly, right, you know, will be the desired form that we want. Well, let's see. All right. Here it says find the vertex. It asks the same question as the previous problems, but this function doesn't look like the previous problem, right? So here, I'm going to complete the square. So I'm going to do what the instructions say on the previous page. I'm going to factor out a from ax squared plus bx. So I'm going to take out a 2 from the 2x squared minus 12x. So this is 2 times parentheses x squared minus 6x. Close that up, plus 7. The next thing it said was to take half of the coefficient of x. Well, the coefficient of x is -6. Take half of it, I get -3. Square it, I get 9. So I'm going to add 9 and subtract 9 within the parentheses. What did I just do? I got it right here on paper. Take half, that's step 2. Take half of the coefficient of x, square it, add and subtract the result within the parentheses. So here, that's the coefficient of x. So what we're going to do is take half of it, -6 over 2. I get -3. And then we're going to square it. I get 9. So now I'm going to add and subtract the 9 within the parentheses. So I'm going to leave in black what I already have, and then here's what we've done. We're going to add 9, subtract 9 within the parentheses. Then plus 7. Now, have I harmed the problem? Have I messed it up? No, I didn't. See? All I've done was just to add a 0 to it. What the late, great Professor Dr. Wallace Maryland would say, all we've done was to add a sophisticated 0. The part that I want is the plus. So I get rid of the -9, so I take it outside the parentheses. So to do that, we have 2 times x squared minus 6x plus 9. Leave that inside. Take the -9 out, but it has to go to the front door. There's only one door to this house, right? Somebody said, I'm the way, I'm the truth, and I'm the light. He also said, I'm the door, right? So I have to take the -9 to the door. The door is the 2. So to take the -9 out, I have to multiply the -9 times 2. I get -18 on the outside, plus 7. Now what's inside of the parentheses now is going to be a perfect square trinomial. I mean, it's sweet now. So now I can just crank that car up. So this is 2 times, this is automatically just x minus 3, all to be squared. -18 plus 7 is -11. Now that looks like the form that I want. This guy looks like a times x minus h to be squared plus k. So this implies then that the vertex is the 3, -11. Now you could have gotten that, here's the other way. You could have gotten that by looking for that value for x, or that is the h, that is the -b all over 2a. If you remember that, you know, this is a, b, c. So we have so times this b, which is -12, all over 2 times a, which is 2. So I get 12 divided by 4. I get 3. That's the 3 here. And then you can get this value here by just plugging in the 3 back into the function. So we say f of 3 is equal to 2 times 3 squared minus 12 times 3 plus 7. So we get 9 times 2 is 18 minus 36 plus 7. So we get 15 minus 36, we get negative 11. So the vertex from that method is the same, 3 comma negative 11. You pick which one you like. It doesn't matter with me. You pick which one you like. You can use the formula, you gotta memorize it, or you can complete the square. The cool thing about completing the square, you will see it forever. And so once you learn it, you keep it, you use it, and I mean, personally for me, once you go through the steps for completing the square once or twice, I mean, it just becomes a part of you. The formula you have to kind of keep in your head, and then you have to ask yourself the question, what is that? You know, what is this 2 over, what's this b over 2a? But don't forget the negative, that's important too. Negative b over 2a. But again, whichever one you like is fine with me. So here, use the vertex, the intercepts. We're going to graph this function, and then they want us to find the domain and range. The cool thing about domain and range, you remember when the class first began, that's what we started with, domain and range. That doesn't change. So the vertex would be, it's in the form already. It's 3 comma negative 1. That's the vertex. The line of symmetry, the axis of symmetry, is always this phrase here. Oops. Thought it was a highlighter. I don't want to white it out. Oh, there it is. Highlighter. Good. So this axis of symmetry is always whatever I have in there. Is this right? So this color. The axis of symmetry is the line. Whatever this is in the parentheses, you set it equal to 0, and then like here you have x minus 3 equal to 0. That implies that we get x equal to 3. So it's the line x equal to 3. So that goes here, x equal to 3. If it was x plus 3, then it would be the line x equal to negative 3. Right? So, and then to get the right graph, we need to find intercepts, either x or y. I'm going to simply just let x equal to 0. So that means I have f of 0 is equal to 0 minus 3 to b squared minus 1. So that becomes 9 minus 1. I get 8. So this is 0 comma 8. That's the y-intercept, right? To find the y-intercept, set x equals 0, solve for y. To get the x-intercept, you set y equals 0, solve for x. It's always opposites for algebra. Right? Everything is opposite. Right? That's why a man and a woman just go together. Opposites. I ain't preaching. I'm just okay. Thank you, Mike. Ooh. Okay. Anyway, so let's see. The vertex is 3. 1, 2, 3, and then negative. Let me get that right. Vertex 3, negative 1. So I'm going to go over x equal to 3, y equal to negative 1. I'm here. And then I'll make sure I get the right y-intercept. That's 8, 0 comma 8. That's over here. Now that vertex, and look, here, if you don't see A, that means that A is 1, is positive. Right? So that means that the parabola is going up. So it's doing this, right? So the domain, as x goes up to the left and to the right, it keeps on going out on both sides. So my domain, the x values, will be from negative infinity to positive infinity. And that typically is the trend with these quadratic functions. Now the range, you have to look at the graph with respect to the y-axis. So I look at the graph and look at the y-axis. Now here, this was negative 1. So the range goes from negative 1 to positive infinity. That's the range. And I mean, here's the thing. You know, make sure you learn these concepts because they stay the same. I mean, that was a cool thing for me when it came to mathematics. Once I learn it, then next year, if I'm taking a different class, if you're talking about the range, it's the same range. So I don't have to relearn the idea of the range. And that's not so with English, because you learn all these concepts in English, and then for a particular sentence or a particular paragraph, things get kind of funny, you know? So, ladies, you all take care. Yep, I wish y'all well. Yep. So the range here would be from negative 1 to positive infinity, right? So for the range to look at the y values with respect to the graph. For the domain, look at the x values with respect to the graph. So here, find the vertex, intercepts to sketch the graph, give the equation for the parabola's axis of symmetry. What I did, I went ahead and completed the square. So I'm going to factor out the 6 from the 6x squared plus the 12x. So I factor out a 6 here. So I get x squared plus 2x minus 7. And then I take half of the coefficient of x. Well, the coefficient of x is 2. Take half of that. 2 divided by 2 is 1. I square 1, I get 1. So I'm going to add 1 and subtract 1 within the parentheses. So this is 6 times parentheses x squared plus 2x plus 1 minus 1 minus 7. Take the negative part out. Take him out. To do that, take him through the front door. The front door is the 6. So this is 6 times parentheses x squared plus 2x plus 1. And then I bring the negative 1 out times the 6. That's negative 6 minus 7 on the outside. What's in the parentheses is automatically a perfect square trinomial. So this is 6 times parentheses x plus 1, all to be squared. Simplify the outside, that's minus 13. So the vertex, this implies that the vertex is negative 1, comma, negative 13. So that goes there. It asks for the X intercepts. That means set the function, that is y equal to 0, solve for x. So to find the X intercepts, set y, that's the same thing as f of x, equal to 0, and solve for x. So basically we have 6x squared plus 12x minus 7 equal to 0. We got to factor this. It's not going to be perfect. It's not going to be sweet and smooth. I wish it was. I mean, how do I know that? Well, I didn't. I worked the problem out before, right? And so it's not like, I got some trick with math and I know what the answer is going to be. But here's what I did do. I said, well, since I completed the square already, I'm going to use that, start from that point, and just keep on going to solve. So that is, i.e., that is to say, this is the same thing as 6 times x plus 1 to be squared minus 13. It's equal to that. That's equal to 0. We set it equal to 0. Then I just solve for x. So I just use my algebra, add 13 on both sides, divide both sides by 6, and then take the square root of both sides, and then I want to get the x by itself. Right? So this is 6 times x plus 1 to be squared is equal to 13. Divide 6 on both sides, I get x plus 1 to be squared is equal to 13 over 6. And then take the square root of both sides. That's going to be plus or minus the square root of 13 over 6. So just on a regular calculator, take that square root, so here I get plus or minus 1 point. And in my math lab, it says like to the nearest hundredth or whatever it says, go by that. So since I don't see that here, I didn't copy that over here. I'm going to write this as 1.47, just say 2. And so now time I did that, I have left, this is just x plus 1 is equal to plus or minus 1.472. So this implies that x is equal to that negative 1 plus or minus 1.472. And it looks like it's to the second decimal, the 100th. So I'm going to just take off that 2. And so I have x of 1 is negative 1 plus 1.47. So we get 0.47. And x of 2 is negative 1 minus 1.47. And I get negative 2.47. Now to write the intercepts, they want those as ordered pair. So that's how we have to say the x value, 0.47, and the y value, we set that equal to 0, you remember? So that's comma 0. And the other value is negative 2.47, comma 0. And you put that in my math lab like that. And then they ask for the Y-intercept. And hopefully, by this point, you're not just sick on your stomach and like, where's the nearest subway, right? So what is the Y-intercept? That is, let x equal 0. So that implies, go back up here, put x equals 0. F of 0 is equal to just negative 7. So I have 0, comma, negative 7. Guess I'm too close down there. 0, comma, negative 7 is the y-intercept. They're asking for all these points so that you can plug them on the XY plane so you can get the best, most accurate graph. Right? Let's see. So we take that information, and they want us to graph it, and so we need this information. So the vertex is negative 1 comma negative 13. I need that. The vertex negative 1 comma negative 13. We had 0 comma, I think it was negative 7 for the Y-intercept. And then we had 0.47 comma 0, and was that negative 2.47?
Yes, sir.
Okay, thank you. Comma 0, and those were our two X intercepts. And here the A is 6 is positive. So that means that the parabola is shifting upward. So if it's shifting upward, that means that the answer is going to be either A or B. You can go ahead and exclude C and D, right? Because those graphs are going down. And so now let's make sure we get the right vertex. The vertex is negative 1, negative 13. So X is negative 1 and Y is negative 13. That's that guy right there. A, the vertex is over here at 1 comma negative 13. You see how they want to, see how they're trying to play on your emotions. You know, if you get that negative sign wrong on that vertex, you end up picking the wrong guy. And so it's B. The axis of symmetry. You go back to how we wrote out this this equation here. Look on the inside of the parentheses, that's x plus 1. That means that x equal to negative 1 is the axis of symmetry. What's the domain? We'll look at the graph with respect to the x-axis. So that as it goes up, it keeps on going to the left. So it's going to cover all those values to negative infinity. As it goes up to the right, it's going up, but it keeps on going to the right as well. So it's going to cover all the way over to positive infinity. So that's my domain, from negative infinity to positive infinity. For the range, I look at the graph with respect to the y-axis. So it has the most bottom value, that was at negative 13, and then it goes all the way up to positive infinity. It includes negative 13, comma, positive infinity. Okay. And then you see how all these concepts are like building blocks from before. So what I want you to do, especially for test 1 and test 2, I want you to really go back and learn that stuff. Make sure we get it, because we're going to keep using that stuff. Hey, here's the thing. You're going to use it all the way up through chapter 2. Chapter 3, I think it's logarithm. So the algebra changes drastically. So, but then if you're taking higher math, you're going to see it again as well too. So, the maximum and minimum. If I know that I have a quadratic function, the maximum and minimum is found at the vertex. We've already gotten the vertex. So if the parabola is shaped up, that means the vertex is that smallest value. That lowest value, that's the minimum. If the parabola is shaped down, the cup is upside down, then I have a maximum up there at the vertex. So you've already found the vertex, no problem. Keep with that concept, and we can get the max or the min at that point. All right. And what is this? Just some more blah, 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 blah. Let's look at this page right here. Consider the function. Determine without graphing whether the function has a minimum value or a maximum value. Well, let me ask you. So when they say without graphing, how could we know if this function has a minimum or maximum?
Negatives.
What's that again?
The negatives.
What negative? I'm sorry.
Like the negative 12 and the negative 3.
Okay, that personally for me that tells me nothing about the minimum or maximum. Now you may have some insight that I don't have. And-
I
and
promise
because-
you I don't.
Well, I mean, look, I understand, man. And when it comes to young folk today, you all are pretty smart. A lot of times, way smarter than old folk like me. So, yes, ma'am.
It's whether or not A is positive.
That's it. It's the A. Remember we said that if A is positive, right, that means that the parabola is going to shape upward. You got a minimum. If A is negative, see, here's the thing, folks. See the math, or even if it's hermeneutics, that's the study of the interpretation of the Word of God. Look, I can't make up stuff. You know, I've stopped in Bible study asking people, what do you think about this passage? It cares less about what you think. It's what the passage says itself. What is God saying in the passage? It ain't got nothing to do with what you say. That's how we've messed up the whole world already. Everybody got their own interpretation. When it comes to math, go back and look at what's already been presented. What's on paper? I got to go on that. I can't just sit there and just, here's what we're doing. We sit in the class going over concepts, this and that, and then a question is asked, and then I forget what we just got through talking about, and I'm trying to figure it out. Look at what we just got through talking about. The answer comes from the pericope, comes from the information there in the passage. Let's go back. Take me back to, the place, okay, where,
It's Thursday now, Sunday.
thank you. What you say? Oh, Lord, I feel my help coming. So look here again. Determine whether the parabola opens upward or downward. If A is positive, it opens upward. If A is positive, then the parabola, if it's this again, you remember the parabola is doing that. That means I have a minimum here. If A is less than 0, the parabola is going down. That means I have a maximum there. So I'm looking at the value A. I'm looking at this value to determine whether it has a minimum or a maximum. Okay? So here A is 3. It's positive. A is 3, that means the cup is shaped upward. That means I have a minimum. F has a minimum. We say in analysis that F achieves a minimum. That's Cauchy Cauchy talk and Leibniz, who worked on calculus during the time of Isaac Newton as well. Let's see. Consider this function. So the minimum value is blank. It occurs at, so here they say the minimum value, that means that the function value. And the x value. All they're saying is find the vertex. So what we're going to do is, I'm just going to complete the square. Factor out the 3 from the 3x squared minus 12x. Take half of the coefficient of x. Well, the coefficient of x is -4. Take half of it, I get -2. Square it, I get 4. So I have plus 4, add 4, and subtract 4 within the parentheses. Then on the outside, I got that -3. So this is 3 times, I'm going to go ahead and do the work. X minus 2 to be squared. Take the negative part out. That's the 3 times the -4. That's a -12, minus 3 on the outside. So we get 3 times x minus 2 to be squared minus 15. So here, the vertex is 2 comma negative 15. So check this out. Once you get the vertex, the minimum, here, this is the same problem as before. That's that problem there. So the minimum value, the function value, well look, that's the vertex value for f. That's that negative 15. It occurs at x equal to 2. It's just the vertex. That's cool. So basically what we've done in the beginning of this course, section, we end with the same thing. Find the domain, and then find the range. Maybe we look at the graph, maybe. I'm going to find the vertex. The vertex is 2 comma negative 15. Oh, I got to go down a little bit further. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So the domain, all real numbers from negative infinity to positive infinity. The range, this is what I need to see. How low does it go? It goes down to negative infinity, negative 15, excuse me, all the way up to positive infinity. Okay. All right, is that okay? A ball is thrown upward and outward from a height of 8 feet. And so when they do that, to be able, bless you, to build this problem, that's the initial height, when x is equal to 0. F of 0, plug in x equals 0, I get 8. So that would be the initial height at 8 feet. The height of the ball is given by the function, where x is the ball's horizontal distance. That is just across the xy plane. Since it's negative, that means that this graph is going to be shaped going downward. It's going to do something like that. That highest point would give me the height. So they're saying that this horizontal distance is x from where the ball is thrown. Use this model to solve parts A through C. What is the maximum height of the ball and how far from where it was thrown does it occur? Basically, they're asking us to find the vertex value, find that F value for the vertex. So what we do here, since these values 0.1, 0.8, those are decimals, I'm going to use that formula. X is equal to negative b over 2a. I'm going to use that. Can't complete the square on decimals. So let's see, a is that negative 0.1, b is 0.7, and c is 8. So I get here, this is negative b 0.7 all over 2 times negative 0.1. And that gives 3.5. Now I find the function value, f of 3.5. This is negative 0.1 times 3.5 to be squared, plus 0.7 times 3.5 plus 8. You work that out, we get 9.225. It's it round to the nearest tenth, so I don't need all that. So we have just 9.2. This is in feet. That's the height, that function value at the vertex. Right. So this point here is x is 3.5 and y is 9.2. So that means that the maximum height, the function value, that's 9.2. Which occurs at, from the point of release, 3.5. Okay. How far does the ball travel horizontally before hitting the ground? So it starts up here. This point here is the 8 feet. That's where it started. So it's saying, what's the distance when it gets there? Find x. This is for part B. Let me ask you, so to get that value over there, that's where it terminates on the ground. What would you propose to get that value? What formula could we use? All answers will be accepted. All answers won't be right, but all answers will be accepted. Let me ask you this. Do you remember the quadratic formula? What's the whole purpose of using the quadratic formula? What does it give you? The quadratic formula, it doesn't give you like two values, usually like some kind of plus or minus and that kind of stuff, you know, whatever. I mean, it don't have to be negative and positive answers, but you get two values. Right. What are those two values called? Do you remember the two values that you get from the quadratic formula? The X-intercepts. That's what they're called. So the term X-intercept in the solution for the function, or the root, or the factor, they all mean the same. They're all synonymous. So here, use the quadratic and I want you to maximize, I want you to understand this problem, because this is one of the problems that's used for the learning outcomes for this course. This problem is key. You see where I said here, find x for part B? Look at it. See where I got that arrow? That's where the graph intercepts with the x-axis. That's the x-intercept. So I can use the quadratic formula, because the quadratic formula says that if the quadratic equation is equal to 0, basically you're setting y equal to 0, solving for x. X-intercept. To find the x-intercept. So here, this guy's the x-intercept. So remember, it says this, and this if is important. If ax squared plus bx plus c is equal to 0, then I use the implication here, the mathematical symbol. This implies that x is equal to negative b plus or minus the square root, yes, of b squared minus 4 times a times c all over 2 times a. Yes, ma'am. So we got negative, well, b is the 0.7. That's plus or minus the square root of 0.7 to be squared minus 4 times a. That's negative 0.1 times c, that's 8, all over 2 times a, that's negative 0.1. Simplify that, and to not take the time, I simplified that. So this is negative 0.7 plus or minus, do that on your calculator. You get 1.92 all over 0.2. We get two values. X of 1 is 0.7 minus 1.92 over, oh no, I hit the wrong button. It's not good. And this is not good when I'm recording. I don't like that. Okay, we got it back. Oh boy. I need to write somewhere else. I guess I'm too low down there. Woo! Mercy. Better right here. So x of 1 is negative 0.7 minus 1.92 over and that gives 13.1. Then the other value, x of 2 is negative 0.7 plus 1.92 all over negative 0.2. And that's negative 6.1. So my question to you is, which of these x's is this point here? Hmm? 13.1, right? Well, how come it's not the negative 6.1?
Because it's not below the x-axis.
Because it's negative, right? We're talking about a ball that is actually thrown, right? So that has to exist in the real world. So here the real world would be in that first quadrant, right? So if I'm talking about something with a real distance in life, that distance has to be positive. So this is, and yes, Michael, you're on it too, and thank you. And it's Maggie? Yes. Okay. So this is x equal to 13.1. And so that's the value here, 13.1 feet, okay? Now the problems here, they're just fun problems to do. Oh, we gotta graph this. Do you see where C and D are excluded? Let's start with C. Do you see why C is definitely not the shape? Yeah, look, it's going from 0 to 20. Look, we just said that it touched down at 13.1 on the x-axis, right? Well, it's not A because this is touching down at like 16, something like that. Now D looks to be okay over here on the x-axis, but it started at y equal to 8. You remember it said that? The initial ball is thrown on the y-axis at y equal to 8. It looks like it's that. And then we just found that from the quadratic equation, the formula, we got x equal to 13. It's that. Okay? Does that make sense?
Yes, sir.
All right. Find all pairs of numbers whose sum is 20. When you say sum, let's say the two numbers are x and y. Let x and y represent the two numbers. Let x and y represent the two numbers. So then if that's the case, how would I write the sum of x and y? How would I write the sum of x and y? When you say the sum of two numbers, how do you express that? What does sum mean anyway? S-U-M. Okay, our time. We're adding, so sum means to add. So if it's the sum of two numbers here said to be x and y, that means that x plus y represents the sum. It says the sum is that's equal to 20. Right? It says whose product is as large as possible. Whose product is as large as possible. How do I get the product of x and y? How do I express that mathematically? Product means what? You're a product of your generation. We're not talking about that. We're talking about mathematically. You say product, that means what? I want to do what with these two numbers? Multiply. Thank you, Mr. Devin. I like your hat, by the way. So I want to multiply. So here it says that the product is as large as possible. So that means that they want to maximize. I'm just going to say P equals the product x times y.
4 and 5. 4 and 5.
No, we got to work the problem. We have to do the math. Right? This is a math class. This is not a guessing class. Because it says the sum, does 4 plus 5 equal to 20? It says the sum has to be 20, right? See that? I got to work both of these constraints together. So I'm going to work the problem. So here's what we're going to do. It says as large as possible. I need to maximize P. P represents the product. Let P represent the product. P represents the product. Right? So that means I need to focus on P by using a secondary equation. The secondary equation is x plus y equals 20. So that means that I need to write P with one variable. Well, I can do that. Check this out. I can write y from the first equation that y is equal to 20 minus x. Then I can replace the y for the second equation with 20 minus x. And then maximize it. Oh boy. So solve for y from the first equation. So I get y is equal to 20 minus x. First thing we do. Second thing we do is replace this value for y in the second equation. Replace y in the second equation with the result from step 1. So that means that I have P is equal to x times, but now y is 20 minus x. Right? Step number 3, simplify. So here I get 20x minus x squared, but this is negative x squared plus 20x. Step 4, use what we know from this section to find the vertex. This is a quadratic equation. Find the vertex. It doesn't have a C over there, that's fine. But I can work the process. So this is, this is negative 1 times x squared plus 20x. So I'm going to factor out a negative 1, that a. So it's negative 1 times x squared minus 20x. I'm going to take half of the coefficient of x. Well, the coefficient of x is negative 20. Take half of that, I get negative 10. Square 10, I get 100. So I'm going to add 100 and subtract 100 within the parentheses. Take the negative part out. So this is negative 1 times x squared minus 20x plus 100. Take the negative part out. That's negative times the front door. Negative 100 times the negative 1. That's plus 100 on the outside. I can factor the parentheses. It's a perfect square trinomial. It's always the square root of the first term and then the square root of the second, that last term, excuse me. So it's just x takes the sign here, whatever that sign is, negative 20, x, it takes the sign right there in the middle. So it's x minus 10 to be squared plus 100. The vertex, what I need. The vertex is 10, comma, 100. So what is x for this problem? X is equal to 10. I just found it from the vertex. X is 10. If x is 10, y is 20 minus 10. So here it says the pair of numbers whose sum is 20 and whose product is as large as possible is the pair of numbers. Okay, the pair of numbers would be 10 and 10. I'm trying to read the question. Yeah, and I just replaced it right here. And then it says the maximum product. Well, the product is always what you got from the vertex. It's that F value. It's the 100. But anyway, you could just multiply them. 10 times 10 is 100. Well, maybe I can start the next problem. Yeah, maybe I'll start this one and then I'll let you finish it. How about that? Let's just set it up for right now, and then I think you can finish it after that. Let's talk it through. You have 200 feet of fencing to enclose a rectangular plot that borders on a river. Isn't that pretty? If you do not fence the side along the river, obviously, unless you got bandits that's going to cross the river, right? But that means I've been watching too many Westerns. Anyway, find the length and the width of the plot that will maximize the area. So I'm going to add up these sides, and that gives me 20. So that's the parameter. So I have x plus x. So I get, well, just write it out so you can see it. So x plus 200 minus 2x plus x. That's all sides has to equal to 200. Does that make sense? That's the parameter. Add up all the sides, right? Okay. And then it says, the second equation, the area. Remember the area, this is a rectangle, so the area has to equal to the so-called the length times the width. The length times the width. So the length would be, let's say the 200 minus 2x, and then the width would be x. 200 minus 2x times x. Now let's get this parameter straight. Does that make sense? So think about it. This is x plus x, that's 2x, minus 2x. That cancels out. That's 200 equal to 200, so that means that this is good. Can't do anything with it, but that's no problem. I'm going to use this guy right here. So let's simplify this. This is 200x minus 2x squared. It says find the length, find the width. The same as the previous problem. Here, this is a quadratic equation. So let's write this as, and this is that area, write this as the negative 2x squared plus 200x. Complete the square. Negative 2 times parentheses x squared. I factored out a negative 2, so that's going to be a negative 100 times x. Again, negative 2 times negative 100 is positive 200. Right? So it's negative 2 times x squared minus 100x. The coefficient of x is a negative 100. I take half of that, I get 50. I'm going to square that, right? And then I'm going to add that and subtract that within the parentheses. So I square 50, get 2,500 minus 2,500. Close that up. Take the negative part out. I have negative 2 times, this is x squared minus 100x plus 2,500. On the outside, this is plus 5,000. And this gives me negative 2. Factor the parentheses, perfect square trinomial. This is x minus 50. All to be squared plus 5,000. So x is 50. So if x is 50, the y value, this is x, that's 50. That means that this y value is 200 minus 2 times 50. That means that y is equal to, what is that, 100? So here it says the width that's labeled x, that's 50. The length, 200 minus 2x, we got that to be 100. The largest area that can be enclosed is this length times the width. Well, it's just multiplying these two numbers, right? So that's multiplying here the 100 times the 50. And we get the 5,000. And you knew that anyway from the vertex, right? The vertex is 50 comma 5,000. And that next problem works exactly the same. I'm going to stop right there.